These are the notes for Unit 6 Day 11, and we're going to continue our discussion about our complex numbers. Again, this is a kind of we call it imaginary friends, but really what we're talking about is our complex numbers. And so this is, we learned the basics about complex numbers in the previous section, and this is where they kind of come into play. And that is if we consider the quadratic formula. It looks like this is the kind of the focus of the discussion here, right? If we consider the quadratic formula, which is opposite b plus or minus the square root of b squared minus 4 times a times c, and that's all under the square root over 2 times a, to find our solutions, then we have a component of this quadratic formula is this pattern of b squared minus 4ac, and we call that the discriminant. Oops, I think I spelled that wrong. Let's try that again. Discriminant. And so let's get rid of a couple of these dots here. There we go. And that forms the basis of what the solutions look like and what the parabola looks like. So if we look at setting up the quadratic formula for each one of these questions, so let's take question 1 here. A is 1, B is 2, C is minus 5, and then we're looking at the discriminant here. So setting up the quadratic formula looks like opposite of b, it's negative 2, plus or minus the square root of b squared, 2 squared minus 4 times a times c, all over 2 times a. Setting that up, then come on, there we go. Setting that up and then calculating the solution looks like minus 2 plus or minus the square root of, and then let's take a look at 2 squared. So 2 squared minus 4 times a times c, negative 5. So that's 24. All over 2 times 1, which is 2. So that b squared minus 4ac, that discriminant, that is, in fact, we could just do this. Grab this, duplicate it, bring it over here. That's the discriminant. That's the 24. So we notice that that is that 24 is a positive number, and when we solve this to get the two answers, we get minus 2 plus root 24 over 2 and minus 2 minus root 24 over 2. And since root 24 is not a perfect square, we're going to get decimals here. So I'm just going to put that in. Minus 2 plus square root 24. And I got to come outside the square root, put my brackets. That's the numerator, divided by 2. So notice I've grouped the numerator. And I've got to calculate. Oh, I see. I've got a calculation error because I've got some brackets here that I don't need. Don't know how I got those there. Let's get rid of those. There we go. There we go. That's 1.449, let's call it. And then let me just bring that in here and put the minus sign. That's the advantage of this calculator. And we've got negative 3.449. So we have negative 3.449 and positive 1.449. And so we have, it's hard to see, there's actually a grid there. It's hard to see on this, in this file though. So let me just shrink this down a little bit. So we know we have two solutions. And we know we have something that looks like this in general terms. So we have two solutions here. So we have two solutions, and the solutions are what we calculated above. They are real numbers, right? They're part of the real number system. You can tell because it intersects the x-axis in two spots, and it goes back to this. It goes back to this discriminant being positive. Okay, so compare that to this next quadratic, where a is 2, b is negative 8, and c is positive 8. And we set up the quadratic formula here. So the quadratic formula says opposite of b, that's 8, plus or minus the square root of negative 8 squared minus 4 times a times c, all over 2 times a. So when we calculate that, that's negative 8 squared minus 4 times a times c. And notice that is 0. So this discriminant here, this value underneath the square root, that's the discriminant, is equal to 0. Okay, so it's neither positive nor negative, it's 0. Well, when that's 0, then this leads to 8 plus or minus the square root of 0 over 4. Well, we don't need the plus or minus the square root of 0, that's just 8 over 4, and that's just 2. So now we have a single solution. It only crosses the x-axis in that one location. So one intercept. One intercept instead of 2 intercepts. Okay, so how many solutions do we have here? We have one solution. It's still real. It's still a real number. It's 2, right? It's x equals 2. But it's because we got that 0 underneath the square root that what happened is we were able to get rid of the plus minus option. So we only have one solution there, and we have this parabola that the term we use is we use the term tangent. It's tangent. This is tangent to the x-axis. And then looking at this last example, a is negative 1, b is 2, and c is 3. Ooh, careful. C is not 3. We need to bring the 3 to the other side so that we can get it written in x squared plus 2x minus 3, the equal to 0 form. So c is negative 3. And calculating the quadratic formula here, opposite of b is negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, which is negative 1, times c, which is negative 3, all over 2 times a, 2 times negative 1. And so here we have minus 2 plus or minus. Let's see what this discriminant is. So then we're going to calculate this discriminant. All right, we know that goes down there. So we've got 2 squared minus 4 times a, which is -1, times c, which is -3. That's why we use those brackets with all that stuff. And this is -8. So this is -2 plus or minus the square root of -8 all over -2. I'm going to move that. It's kind of getting lost. There we go. And in this situation, we have that square root of -8. So I'm going to rewrite this as -2 plus or minus the square root of a +8 times I. I'm going to get that negative sign out from underneath the square root over -2. And so we have a complex expression there. So this discriminant here is negative, and that's what led to that complex expression. So we have a complex solution here. And we still have 2 answers though, right? We still have the plus minus. So we have two complex solutions. It's probably a better way of writing that. Or maybe let's write it the way I have it written up above. 2 solutions, and they are complex because of that I. So what does that mean for graphing? Well, it's hard to show because we have nothing that's intersecting the x-axis. We have no intercepts. So I think I'm going to rely on graphing this one. We could have graphed the other ones too. But let's just graph this one. -x squared plus 2x minus 3 equals 0. In other words, there's no real number that gets us 0 for this quadratic. And so when we graph it, what we see, hold on here, I must have I do have another equation. Let's get rid of that. What we see when we graph this is we see a parabola. It's upside down because of the -x, but it doesn't intersect the x-axis at all. It looks like this. So we have 0 intercepts. And again, it all goes back to what that discriminant is. And so the nice thing is that we don't really have to go through all of these quadratic solutions. We can just look at the discriminant. So that's the nice thing. The nice thing is that to determine how many solutions we have here, we can just look right here at the discriminant. And that's kind of how we can kind of cut to the chase here and make these problems a lot shorter. So how does the discriminant relate to the number and types of solutions? So this discriminant here, if that discriminant is positive, like the first example up here, we get a positive discriminant. It doesn't have to be a perfect square. We know we're going to get 2 real solutions. So we're going to have 2 solutions, and they're going to be real numbers. And if that discriminant is 0, we're going to have 1 solution, just like that second example, and it's still going to be a real number. And if that discriminant is negative, we're going to have 2 solutions, but they're going to be complex. And what that means is that quadratic is not going to intersect the horizontal axis at all. Okay, so that allows us to answer quicker than calculating the entire quadratic formula. So our learning target then is that we are going to use, we have this quadratic formula, right? We have the quadratic formula, opposite b plus or minus the square root of b squared minus 4ac all over 2a. We have the quadratic formula to calculate solutions, and it'll calculate a solution to anything. But really, what's important here is the discriminant. Discriminant. What's really important is that discriminant tells us the solutions. So our learning target 2 then is going to be, oops, number 2 is really this information up here. I'm just going to slide this, duplicate it, and stick it down here. There we go. Our learning target 2 is when the discriminant is positive. Maybe I'll scoochy that down just a little bit. Oops, get everything. There we go. There we go. Okay, so when the discriminant, let's just do this. Let's just do when b squared minus 4ac, when that is positive, it leads to 2 solutions, 0 leads to 1 solution. Those are both real. And when it's negative, it leads to 2 complex solutions. And so with these check your understandings, I really want you to rely on the discriminant here. Each one of these has a quadratic formula. It's already set equal to 0. I just want you to find the discriminant so that you can answer these 2 questions. How many solutions? And then I would say that you don't need to go back to the quadratic formula, maybe just graph to verify your answers. So if you're getting a discriminant that's positive, you should be getting it intersecting twice. If you're getting a discriminant of 0, intersecting only once, tangent, so to speak. And if your discriminant's negative, you should not have that intersecting at all. So do that, and then you can move on to the homework, which is the same sort of thing, just calculating the discriminant and telling me the number and the type of solutions.